What is a priori? Miss, do you know what a priori is?
Naku, I don't have any idea about what a priori is.
Thousand years later.
All I know is Apriori Algorithm is used for mining frequent item sets in Boolean associative rules, meaning we can apply this in our previous topics in discrete math.
Wow!
Before we proceed on the examples of databases containing transactions and how or when do we use a priori algorithm, let us first discuss what is a priori. A priori is an algorithm for frequent item set mining and association rules over transactional databases. It proceeds by identifying the frequent individual items in the database and extending them to larger and larger item sets as long as they appear sufficiently often in the database. Support says how popular an item set is, as measured by the proportion of transactions in which an item set appears, while the confidence says how likely an item Y is purchased and when item X is also purchased. It is measured by the proportion of transactions with item X and when item Y also appears.
Apriori algorithm. First, I will discuss the meaning of a priori algorithm. What is a priori algorithm? A priori algorithm is an algorithm for mining frequent item sets for Boolean association rules. A priori algorithm uses a bottom-up approach where frequent subsets are extended one item at a time, which is known as candidate generation, and the group of candidates which is being tested against the data. Afterwards, throughout our discussion, we will see the variation of transaction which leads to Boolean association rules. Now we will start to find out the support and confidence for the candidate C1. We have the transaction ID item sets and the candidate for each item set, which is A, B, C, D, E, and F. Support is nothing but the number of items that the item set has been repeated. As you can see, item set A was been repeated 3 times. 1, 2, and 3. Which is equivalent to 3 for the support. While item set B was been repeated 2 times in the support. 1 and 2. While the other one, item set C, was been repeated 2 times again. 1 and 2. While item set D was once that we have calculated, which is equivalent to 1. While E is equivalent also to 1 and F is equivalent also to 1. As I have said earlier, the number of support is equivalent to 2. And when the support is less than the support given, it will be ignored. And this particular item set, which is equivalent to number 1, will be ignored. As we have calculated the support for the candidate C1, as you can see, I will make another pair of item set for this item set, which is equivalent to AB, like that, and AC, as you can see, and BC. Then we will find again the support for this item set for that candidate. As you can see, as a pair AB was been 1 time repeated, and AC is 2 times repeated. Then I will input 2 as the support, while BC is once been repeated. So I will put 1 as the support. As I observed earlier, when the support is less than the given support, it will be ignored. As you can see, AB and BC has only 1 support. Then that means that AB and BC will be ignored for this item set. Now that we have calculated the support for the item set AC, we have to find the associative rule because we cannot separate this because they are pair. Since they are pair, we have to find the associative rule, which is A leads to C and C leads to A. As you can see, we find the support is equivalent to 2 and also 2. Then we will find the confidence. Confidence is equivalent to number of support over number of appearance in the item set earlier. As we can see, for this confidence is equivalent to for the support and over 3 because A was been repeated 3 times in that item set, which is equivalent to 0.66, while C leads to A which has the support of 2, and when we find the confidence, which is support, which is equal to 2, divided by number of appearance, as we can see, letter C is being repeated 2 times in that item set, which is equal to 2 over 2 equals 1. Then we will find the confidence percent. We get 66% and 100%. As I have said earlier, when the value that was been found was less than the confidence, that would be ignored. As we can see, we get the 66 and 100%, which is greater than 50%. Then, therefore, I concluded that the item set that we get was being correct.
When we go grocery shopping, we often have an extended list of things to buy. Each shopper has a distinctive list depending on one's needs and preferences. A housewife might buy healthy ingredients for family dinner, while a bachelor might buy beer and chips. Understanding these buying patterns can help to increase sales in several ways, such that if an item is bought frequently with another item, for example, bread and milk, when you go to the store, wouldn't you want the aisles to be in an order in such a manner that will reduce your effort to find things? For example, I would want a shampoo, a conditioner, and other hair products to be in one aisle. This is done in a way in which we find association between items. Both X and Y products can be placed on the same shelf, so that buyers of one item would be promoted to buy the other. Promotional discount can be applied to one out of the 2 items. Advertisements on X could be targeted to buyers of Y. An X and Y product could be a combination of a new item. The question is, how do we uncover these associations? In order to understand the concept better, let's make a simple dataset, and we call it the coffee analogy. This dataset consists of the items purchased from a retail store. We have this association rule. Rule number 1. If milk is purchased, then sugar is also purchased. Rule number 2. If sugar is purchased, then milk is also purchased. Rule number 3. If milk and sugar is purchased, then coffee powder is also purchased of 60% of its transaction. Generally, association rule uses if and then format, but we may use antecedent for if, the left-hand side, and consequent for then, the right-hand side. From the above rules, we understand the following explicitly. If milk is purchased, then sugar is also purchased, or vice versa. If milk and sugar are purchased, then coffee powder are also purchased. For example, if we see milk as a set with one item, and the coffee powder as a set with one item, we'll use these to define sets with 2 items like milk and coffee powder. Later, we'll see which product will be both purchased in our basket. If we will find the suitable right-hand side or the consequent, we will show this as coffee to milk, as coffee as the left-hand side and the milk as the right-hand side. We find that milk and coffee to tea, which means that a person who buys milk and coffee has a possibility on buying tea. Item set is a mathematical product of grocery aisles, liquor aisles, eatery aisles, and breakfast aisles.